All right, 3.2 notes, parent graphs and transformations, page 5. So we're going to compare and contrast the four parent functions and apply transformations to their graph. So the first function that we're going to talk about is the absolute value function. You'll know it's an absolute value function when you see the absolute value symbol inside the equation. So when you see this symbol here, you're not going to know it's going to make a V-shaped graph. And if this number in front is a negative, it's going to make it flip over the x-axis. And then the vertex is at C, comma D. Opposite, same. So if you were to make a table of our parent graph and pick the numbers -2 to +2, the absolute value of -2 is 2. Absolute value of -1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. And absolute value of 2 is 2. So then we can plot these points on our parent graph. So you go left 2, and then up 2, left 1, up 1, 0, 0, 1, 1, and 2, 2. Notice it's creating this up 1 over 1, 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 up 1 over 1 pattern. So you should be going precisely through the up 1 over 1 pattern, making a V-shaped absolute value graph. Now for the transformation, notice that we have inside the absolute value brackets this x minus 3. There's two ways you can think of where the vertex is going. You can think of this as opposite same to find the vertex, or you can think of this as setting it equal to 0 when it's inside something. So that would mean you would set x minus 3 equal to 0 and then add the 3 over. Either way, you should know your vertex is at +3, comma 2. So that's your opposite same. This is your left to right direction. This is your up and down direction. So this would mean that we're going to go right 3 and up 2 because you go opposite same, right 3, up 2. So if you remember the vertex of our absolute value graph, it was at 0, 0, but now we're going right 3, up 2, put the dot. And then the pattern for the V-shaped graph was to go up 1 over 1, up 1 over 1. Also up 1 over 1 in the other direction. And then draw on your V-shaped graph. All right, for quadratic, you'll know it's a quadratic graph when you have the squared exponent inside your equation. So notice this does not have the absolute value symbol, so it's not going to be V-shaped. Instead, it's going to be U-shaped. And it's the same properties. If the number in front is negative, it flips on the x-axis and your vertex is a CD. You don't have to write these every time. So we're going to make this table. I'm going to choose the same numbers, but this time I'm squaring the numbers. So when you square -2, it becomes a +4. Squaring -1 becomes a +1. Squaring 0 is 0. Squaring 1 is 1. And squaring 2 is 4. So plotting the points, we have -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Notice this does not make a V, it's making a U-shaped graph. That's your quadratic equation. Some people think they have to memorize this table. They don't. So if you know where the vertex is, and you know that the exponent is squaring, you can go right 1, and 1 squared is 1. Go right 2, 2 squared is 4. Go right 3, 3 squared would be up 9. So notice you don't have to memorize this. You just have to know you're squaring the numbers from the vertex. So when we transform this, when I look at here, remember we're finding the vertex where it's the opposite of this and then the same. So this would be a -1 and then the same would be a -3. Remember, inside is your left to right, so that means I'm going to go left 1 and then same down 3. So the vertex is no longer at 0, 0. We're going left 1, down 3, put a dot. This is the dot we're going to count everything from. And notice we're squaring the numbers from that dot. So going right 1, 1 squared is 1. And then notice I can fold that over the vertex because I know it'll have symmetry with the vertex. To find the next point, go back to the dot. I'm going to go right 2. 2 squared, going right to 2 squared is up 4. 1, 2, 3, 4. That's your next dot. And then this can get folded over the vertex. I could go back to the original dot, and then I can go right 3. 1, 2, 3. 3 squared is up 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be the other point. So notice you don't need to memorize that table. Just know you're squaring the numbers from the vertex. All right, the cubic function, you'll know it's cubic when you have a cubed exponent, so no longer squared. This is going to be an S-shaped graph. Not sure why they call it S-shaped, they just do. So then the same thing applies. If this is negative, it flips on the x-axis and it's a vertex of CD. So when we make our table, when we cube negative 2, it goes negative 2 times negative 2 times negative 2. That's going to make a negative 8. Negative 1 times negative 1 times negative 1 is negative 1. 0 cubed is 0, 1 cubed is 1, and 2 cubed is 8. So it's going to go off the graph. We're down here at negative 2, negative 8, and then negative 1, negative 1, 0, 0, 1, 1, and then 2, 8 is way up there. This is what they call an S-shaped graph, like so. So again, you don't have to memorize the table. This 0, 0, even though it's not technically a vertex, is called a point of inflection. I'm going to call it the vertex just to make life simple. You're just going to cube the numbers from this point. So going right 1, 1 cubed is 1. Back to the dot. Right 2, 2 cubed is up 8. Back to the dot. Left 1 is negative 1, and negative 1 cubed is negative 1. Back to the original. Going left 2, negative 2 cubed is negative 8. So see, I don't need this table. I can count from the points. So we're going to transform it. Notice that we don't have a number in parentheses here. So I can't do the opposite of the number here, but I can do the same to the number that's on the outside. So my vertex is 0, comma, 2. But notice I also have this negative in front. That tells me I'm going up 2, but there is a flip on the x-axis this time. So if you recall, the S-shaped graph was at 0, 0. Instead, it's going to go up 2, and then we have the dot. Okay, so then I'm going to cube the numbers from that dot. So if I go right 1, 1 cubed is 1, but I have to flip it. So instead of going up 1, I'm going to go down 1. Back to the original dot. If I go right 2, 2 cubed would be up 8, but I have to flip it. So instead of going up 8, I'm going to go down 8. So 1, 2, 3, 4, 5, 6, 7, down 8. Back to the original dot. If I go left 1, that's negative 1. Negative 1 cubed is negative 1, but that's going to flip up 1. Back to the original dot. Negative 2 squared would be down 8, but I flip, so I'm going to go up 8. So 1, 2, 3, 4, 5, 6, 7, 8. It's going to be way up here, and I can create my flipped S-shaped graph that's up 2. All right, the square root graph. You'll know it's a square root graph when you have the square root symbol in the equation. This doesn't get a letter, which is very strange. All the other ones got a letter. So you could call this the half parabola turned. If you want to give it a letter, you could say it looks kind of like a lowercase r and similar actually to the square root shape itself. So again, if it's a negative in front, it flips on the x-axis and the vertex is CD. So here we go. I'm going to be very picky with my table because I can't square root negative 2, so I don't want to start my table at negative 2. The very first number you can square root is 0, because the square root of 0 is 0. The next number would be 1. I can't square root 2. I can't square root 3, but the square root of 4 is a whole number. And then the next one would be all the way up to 9, because I don't know 5, 6, 7, or 8. Those are all decimals. So then when we plug this in, the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. So when I plot this, I'm going to start at 0, 0, 1, 1, 4, 2, and then all the way to the right 9, up 3. So it's going to create, notice it kind of looks like a square root symbol or a lowercase r, however you want to think of it. Make sure you don't go below that starting point or to the left of it. This is the starting point, and then it goes to the right like this. All right. Again, you don't have to memorize the table. Just know you're square rooting from this point. So the square root of 1 is 1. The square root of 4 is 2. The square root of 9 would be 3. So let's transform that graph. So remember, it's opposite same. So your vertex would be a positive 4 and a positive 1. This part inside is your left to right. So the opposite of this would be right 4. Same would be up 1. So instead of starting at 0, 0, I'm going to go right 4, up 1, put a dot. And notice the square root symbol tells me to square root numbers from this point. So the square root of 1 is 1. Square root of 2, I don't know. Square root of 3 is a decimal. But the square root of 4 would be up 2. We're already off the graph, so we're just going to draw in our little R-shaped graph, a little half parabola turned. All right, so we're going to state the transformations of the equations below. So in this case, our vertex is not going left or right any. We can't take the opposite because there's no number inside. But then the same would be out here. So the vertex is at 0, 5. And because this is on the outside, it just means it's going to go up 5. There's no left or right movement because there's no number inside. For part B, it's more complicated. We have a flip on the x-axis, and then my vertex would be 3, 6. So that means I'm going to go opposite, same, right 3, up 6. So flip on the x-axis, opposite is right 3, same as up 6. For part C, we don't have a flip. When I do the opposite, I'm going to get negative 9, comma, there's no number on the end, so that would be 0. So negative 9, 0 would mean that I'm going left 9, up 0 in this case. Last one, we don't have a flip. The vertex is going to be positive 6, comma, negative 3, which means I'm going opposite, so right 6, and same, down 3. Okay, using this equation, y equals x minus 3 squared plus 1, what shape is that graph? Okay, the squared graph would be a U-shaped graph. What is the shape of y equals the square root of x minus 3 plus 1? What shape? All right, the square root symbol tells you it's a half parabola turned. All right, the next one, what shape is y equals the absolute value of x minus 3 plus 1? That would be a V-shaped graph. Absolute value is the V shape. And then what about y equals x minus 3 cubed plus 1? Okay, cubed is S-shaped. Very good. All right, so number 2, we're going to transform these graphs. So notice this has the absolute value symbol, so this is going to be a V-shaped graph. So then our vertex is opposite same. I'm going to go 2, 3, which is right 2, up 3. So don't start at 0, 0. We're going to go right 2, and we're going to go up 3, put the dot. The pattern for the V shape is going up 1 over 1, up 1 over 1, up 1 over 1. Also up 1 over 1 the other way, up 1 over 1. Make sure you draw in that V all across that diagonal pattern. Okay, you can label that g of x if you want, or color it red. It's up to you, but make sure I can tell the difference in your graphs. All right, for b, this is h of x. So notice we have a flip on the x-axis. It's still going to be a v shape because it's an absolute value. There's no number here and there's no number here. So that means I'm not shifting it left, right, up, or down. It's going to stay at 0, 0. But instead of going up and over, I'm going to go down and over in both directions, making my V flip over the x-axis. So notice you can either make that blue or you can label that h of x on the graph. All right, for C, this is not a V-shaped graph. We have a squared exponent, so this is U-shaped. So then I don't see a flip. There's no number in the parentheses, so it's not going to go left or right. Instead, it's just going to go up 4. So my vertex is 0, 4. So go ahead, plot the point 0, 4. And then my exponent tells me to square the numbers from that point. So right 1 squared is 1. Fold that over the vertex for symmetry. Back to the original dot. 2 squared would be up 4. So 1, 2, 3, 4. And then fold that over the vertex for symmetry. And there's my U-shaped graph. Either make this red or label it g of x. All right, for h of x, notice that we have another squared exponent, so it's still going to be U-shaped. This time when I do opposite same, it's going to be going right 4, but I'm not going to go up or down. There's no number on the end. So my vertex is at 4, 0. Go ahead, put the dot. We're going to follow the U-shaped pattern by squaring the numbers. So going right 1 squared is 1. Fold it over the vertex for symmetry. Back to the original dot. If I go right 2, 2 squared would be up 4. And then fold that over the vertex. Back to the original dot, I can go right 3. 3 squared would be up 9. Fold it over the vertex. So you can keep going as much as you can on the graph. Label that h of x or color it blue. Okay, next one. This is not an absolute value, so it's not V-shaped. It's not squared, so it's not U-shaped. It's cubed, so it's S-shaped. There is no flip, and then we do opposite same. So I'm going to go opposite of +1 would be left 1, and then down 2 for same. So starting at 0, 0, you're going to go left 1, down 2. That's going to be our point of inflection or vertex that we count from. We're going to cube the numbers from this point. So right 1 cubed is 1. Back to the original dot. Right 2. 2 cubed is 8. So 1, 2, 3, 4, 5, 6, 7, 8. Put a dot. Back to the original point. Now I'm going to go left 1. Negative 1 cubed is negative 1. Back to the original dot. Left 2 cubed is negative 8. So 1, 2, 3, 4, 5, 6, 7, 8 is down here. And there is my S-shaped graph. Make it red or label it g of x. For h of x, this is not a cubic function, so it's not going to be S-shaped. Instead, it's the square root function, which is that half parabola turned, or the lowercase r if you prefer. So there's no flip. We do opposite, same. So right 3, up 4. So starting at 0, 0, I'm going to go right 3, up 4, put the dot. That's going to be the start of my square root. And then I'm going to square root the numbers from that dot. So starting here, the square root of 1 is 1. Back to the original point. The square root of 2, I don't know. The square root of 3, I don't know. Going right 4, the square root of 4 would be up 2. I could go 5, 6, 7, 8, 9. The square root of 9 is up 3, but that's good enough. We have our R-shaped graph. Blue or h of x. All right, using these problems, using this graph, what is the equation of that graph? Okay, so your vertex is right 2, down 4. So opposite same. It should be B. Opposite right 2, down 4. What's the equation of this graph? Okay, so it is R shape, so it's a square root graph. And we went left 3. So that's this one going left 3. Opposite of this one, there is no up or down. This would have been down 3. This would have been up 3. So this is your left 3. Okay, what is the equation of this graph? Okay, so this graph was shifted up 2. It's S-shaped, so it's cubic. So that would mean this is our equation. This would have shifted the graph down 2. This would have been left 2, and this would have been right 2, because when it's inside, it's your left to right, and you go the opposite direction. So this is the answer. Okay, last one. Which one of these equations gives you this graph? Okay, notice it's flipped, so I know it's going to be one of the first two because it's flipped over the x-axis. Then my vertex is left 3, down 1. So opposite, same. So this should be your equation. Okay, now I'm going to give you the graphs, or the equation, you're going to give me the graph. So if I have this, it's a squared graph, so it's U-shaped. Which of these is that graph? Okay, we have opposite, same. So it's going to be right 3 and then down 4. So that would make your answer A, right 3, down 4. Okay, what's the graph of y equals x plus 2 cubed minus 1? Okay, opposite and same. So it's going to be left 2 and then down 1. So that would be D. All right, for the next one, y equals negative square root of x plus 3. Okay, so notice the negative, they're all flipped over the x-axis, so that doesn't really help us. But then you do opposite same. So my vertex is at 0, 3. So that would mean I'm going up 3. So the answer is C. And then last one, y equals the absolute value of x plus 2. What's the graph? Okay, so you go opposite and then same. So that would be negative 2, 0. So the answer is B, going left 2, up 0. Okay, so then using this combined shape here, we're going to transform. So notice we have taking the original function and go minus 1 at the end, which just means I'm going to go down 1 from all of the points. So that's my shifting is down 1. So starting at this point, just go down 1. Up here, go down 1. From 0, 0, down 1. From the V, go down 1. And the rightmost point, go down 1. So it should curve to make a U and then connect to make the V. For part B, notice the x minus 1 is now inside the parentheses. That means this is going to be opposite. So it's going to be right 1. And then there's no number on the end, so there's not going to be an up or down. So starting on the point here, I'm just going to go right 1, right 1, right 1, right 1, and right 1, creating the U and the V. Okay, for part C, we have the x minus 1 inside, so that means it's going to be right 1. And then you do the same, so up 2. So from each dot, go right 1, up 2. From here, go right 1, up 2. From 0, 0, go right 1, up 2. From the V, go right 1, up 2. And from the endpoint, go right 1, up 2. Curve to make the U, and then make the V. For D, you're going to go opposite and same, so that's going to be left 4 and down 3. So starting here, you go left 4 and then down 3, put the dot, And do that for each point. Left 4, down 3, left 4, down 3. So you get your U and your V. All right, for E, we have a negative in front with no number inside or on the end, so it's not going to shift left or right or up or down, but there will be a flip on the x-axis. Remember, this is your x-axis. So this point isn't going to go anywhere, but this point up here is going to flip down over the x-axis. So since it was up 4, it's going to flip to be down 4. 0, 0, it's not going to go anywhere. It's going to stay there. The V is going to flip up 2 over the x-axis, and then this point isn't going to go anywhere. So now the U is going to be down at the bottom, and the V is on top. We haven't talked about this one yet, but when you have a negative inside like this, that means it's going to be a flip on the y-axis. So this is the y-axis. So starting here, this is going to flip from left 4 to become right 4. This is going to flip right 2. This is not going to go anywhere. The V flips over the y-axis to be left 2, and this flips to be left 4.